This conference will now be recorded.
Welcome to my 18 webinar. So today my topic is RAC Architecture 19C, and whatever I will tell you regarding RAC architecture, it will be based on 19C. That will be supported 2026. So that's why I have taken RAC Architecture 19C, but I will start from the basic. So not too much in the deeper. And as you know, my name is Ahmad. This is my certification. This is my blog. This is my YouTube channel. And let's begin with database configuration. So as we know that Oracle database can be configured in two basic ways. Okay, one is single instance that we called as non-database cluster or non-cluster, and another one is multiple instance, or we can say RAC database or real application. RAC means real application. So these are the two ways sorry, where your database will configure. So in single instance, you can see that a database has a one-to-one relationship between the instance, memory, and processes. If you see this figure, just take me a pointer. So see that here database instance and memory, and here your storage. So that is the single instance. And in RAC environment, you have one too many. So this is a one database, but it has one relationship. It has one relationship with instance. So there one too many relationship excuse me, between the database and instance. And sorry, and in database we can add 100 instance in one database, and all the servers for a single database in the RAC environment basically belong to the same Oracle application cluster. Okay, so this is the basic difference between RAC and single instance. So this I have said database can be configured in two basic ways. One is single instance, another one is multiple instance. In single instance, we have Oracle software, database files, and memory and processes, and all on one server. And here we have one-to-one relationship between instance, memory, processes, and the database. Okay, and in RAC we have one-to-many relationship, and we have 100 instance in database we can configure, and all the servers belongs to one RAC environment. So that is said about that. So now if you see this picture where you have shared storage, and you have multiple server, and all are interconnected, no single point of failure, and your user can connect through cloud or direct can connect to this. So this is the real application overall picture. And if you go in detail, when RAC word introduced, so little bit RAC evaluation I'm telling. From Oracle 6 to Oracle 8i, we called OPS, Oracle Parallel Server, and that was around 1990s. And in 9i, release 1, release 2, RAC word came into the picture. It is almost 2001. And in 10g, you have RAC, where ASM introduced to storage purpose for the RAC. And in 11g they have introduced ready to run, and in 11g release 2 they have Oracle RAC one node, and from 12c R1 we have many things in terms of RAC. So that was around 2003. So this is a little bit about RAC evaluation. And if from 12.1 we have grid, and in grid basically we have ASM is bound with that, and Oracle Clusterware. Okay, and you have RAC one node, and you have RAC one node another. So this is the things which introduced, and also Flex ASM introduced. And in 19C, this is the only one option is available for RAC. So we discuss later on little bit about Flex ASM, but that is very deep, so I can't cover here. Uh, I can't cover here too much. So let's begin with cluster. This is the first term which come in the RAC. So cluster is nothing but a group of interconnected computers, and they behave as a single system, and it will give you performance. It will increase the availability, and it will reduce the workload. So this is basically a cluster. And Clusterware basically is a software that provides interfaces and services for a cluster, and it is a required component of RAC. Without Clusterware, you can't run the RAC, so that is mandatory. And Clusterware basically provide the infrastructure which is required to run the Oracle RAC. So Oracle Clusterware will manage resources in that. One is virtual IP or virtual internet protocol addresses and database listeners and so on. So this is the work of Clusterware. And if you see the diagram of real application, so see that you have node, and in that you have shared storage, and another side you have public network, and between the nodes you have private network. So basically each cluster has GI, that is grid infrastructure, installed locally on each node of the grid infrastructure. And grid infrastructure includes basically ASM and others important resources. And each instance in the RAC cluster access the database, and which actually files is stored on the shared. So each node also require local storage, which is used to store the GI and Oracle database software. So each nodes at least a public interface and private interface. So each network must use multiple network interface cards, that is Oracle recommendation. So that will increase the bandwidth and availability or fault tolerance, you can say that. So Oracle recommend that each network should be used multiple network interface card, that is NIC per node, and also multiple switch you can use in each network to avoid a single point of failure. So this is the recommendation, but not mandatory. Okay. And Oracle Clusterware is basically a portable cluster management solution, and that is integrated with Oracle Clusterware, which is a required component. I said that, which provides the infrastructure that I said already. So that I have written, I think here, yeah, and this I have tell. And Oracle Clusterware is the only clusterware that you need for most platform on which Oracle operates, Oracle RAC operates. If suppose your database application require vendor cluster, so then you can use such cluster with your Oracle cluster if that vendor clusterware is certified for Oracle RAC. So that is important point about third-party clusterware. Got it? Any questions?
No, no.
You can use the chat room, my dear. Okay. Meanwhile, you are typing. I will come to later. Please write all the questions on the chat room, and after the session, I will pick it. So now come to RAC database. So as I said, in RAC database, we have multiple instances, and RAC database basically uh, 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 mm, uh, a single database, a set of single database files which reside on the shared storage. And shared storage basically provided by an ASM instance. If you see the figure, we have this shared storage, and after that we have ASM instance, then we have RAC instance. So this plays an important role. Basically from Oracle 19c, there is only one configuration option which is available, that is flex ASM. So that is the important point. And what is flex ASM? In version prior to 12c, the ASM instance need to be run on each of the node of the cluster. In case ASM was not able to start, the database instance located on the same node was not able to come up. Okay, so there were a hard dependency between the database and ASM instance. So with Oracle Flex ASM, database are able to connect remote ASM using network connection. Basically, that connection is called as ASM network. So in case of ASM instance fails, the database instance will reconnect to another ASM instance on other node. So this feature is called as Oracle Flex ASM. Okay, so this is Flex ASM. So from 19c, this is the only configuration option is available for your rack. Clear? Yes. Flex ASM is mandatory in 19c. So if you see this picture, RAC database instances, so see that you have SGA, you have in memory, you have buffer cache, you have background process, you have global process, you have Oracle Clusterware, and between the two instances, your block will be transferred through cache fusion, and your cluster interface, you can say, communicate between these two things. So that is called as a global resource directory, or indirect way you can say global NQ services. And this is your GCS global cache services. So these two body will come under the GRD. Okay, so RAC database, we know that a set of files on the shared storage and can span multiple nodes. And in RAC database instance is a set of process and memory that operates on the database file. So RAC database instance reside on one node, and then it communicates through the global processes and clusterware with other RAC database instances in the same cluster. So a RAC database instance has the same memory and background process as a single instance database. So with the addition of cache fusion and global process, cache fusion is basically, I said that is a diskless cache coherency mechanism in a RAC, which actually provides the copies of the blocks directly from holding instance memory cache to requesting instance memory cache. So this is the work of a global cache mechanism, and this provides basically a logical merging of the SGAs across the database instance. So in the cluster, so global process basically provide the necessary services to maintain the cache coherency and recovery in the event of node failure. So cache fusion and cluster interface both basically use the private network, or you can say interconnect, for communication between the cluster nodes. So this is a RAC database instance. So this whatever I have speak, it is written over here. Now come to RAC tools. So what are the tools we have available? One is CVU, Cluster Verification Utility, OEM, SQL Star Plus, Database Configuration Assistant, Fleet, Patching, and Provisioning. So we know that CVU is the command line tool that you can use to verify a range of clusterware and RAC component like shared storage device, network configuration, system requirements, and Oracle clusterware. Okay, so in addition to operating system groups and user, so you can use a CVU for pre-installation checkup. So when we install the rack, so basically we run the CVU as a pre-installation check, and also you can run after the installation, so that is post installation check. So basically CVU is useful during pre-installation and during installation of Oracle clusterware and RAC component. So Oracle Universal Installer run CVU after installing Oracle clusterware and Oracle database to verify your environment, and install and use CVU before you install OracleRide. So that you can ensure that your configuration is everything is okay for your rack installation. Because meanwhile, if you didn't run that, so in meanwhile, if suppose your installation is stopped, then it is very difficult to do that. First you will deinstall, and then again you have to install. And OEM, we know that this is the cloud control GUI interface to manage both, both non-cluster database and RAC environment. So Oracle recommend that you use Oracle Enterprise Manager to perform administrative task whenever feasible. Okay. And also you can use OEM for RAC one node database also. And SQL Star Plus is a ever-growing command line tool, and that the current instance can be either the local or default instance and which you initiated SQL Star Plus session, or it can be a remote instance to which you connect with Oracle Net Services. And SRVCTL is a command line interface that you can use to manage Oracle RAC database from a single point. So you can use SRVCTL to start and stop the database, and to start and stop the instances, and to delete or move the instances and services. And you can also use SRVCTL to manage configuration information. So Oracle RAC one node and Oracle clusterware and ASM both will be managed. And the fifth one is DBCA, basically to create and initially configure Oracle RAC one node, and Oracle non-cluster databases. And fleet patching and provisioning, basically to patch, upgrade, and provision of your Oracle databases. Okay, so now come to data files in RAC. So as we know that we have data files, control file, redo log file, password file, server parameter file, backup and recovery file, and temporary file. So which files are common and which files are separate? So as we know that each instance must have access to all the data files, including the data files associated with undo table space and control files. So each instance must have an undo table spaces dedicated to particular instance, and all the undo table space must be on shared storage, and redo log file must be accessible to all instances, and each redo log file should be multiplexed as in a single instance. So when using ASM with normal redundancy, each redo log member is mirrored, and a second multiplex member is placed in a different disk group. So each instance must have at least two redo group that is called as thread. So redo log file are not shared, but readable you can do that. So term file basically shared temporary table space are in shared storage, and can split to local storage when using local temporary table space. Okay, so you can create a shared temporary table space by specifying the temporary table clause. And a shared temporary table space basically stores term files on shared disk, so that temporary space is accessible to all database instances. And from release 12.2, you can create a local temporary table space by specifying the keyword that is local temporary table space clause. So local temporary table space is useful in Oracle Clusterware environment. So they store a separate non-shared temp files for each database instance, which can improve IO performance. Okay, so local temporary table space must be a big file table space, that is recommendation. So there should be in terms of control file, there should be at least 2 control file to all instance. As with redo log file, each multiplex control file should be placed in a different disk group. And SP file is a common or sorry, default SP file with both the common parameter and instance specific parameter is highly recommended in shared storage. An ASP file can be stored in ASM, and some initialization parameter must be same across all instance and in a cluster, and some must be unique per instance. So most parameters should be the same to maintain consistent behavior. So this is the thing. Each node have its own redo log. Yes, each node have its own redo log. And the database password file may be placed in a shared storage or maybe on each local node. So this file contains the password of privileged user, those who have sysdba, sysbackup like permissions. Okay, and must be available when the database is not open. Clear? I hope my page is okay. Now server parameter files more information. So if you see that init rac01.ora, init rac0.2ora, and in shared storage, both are pointing. So what does it mean? When you create the database through DBCA, so DBCA creates an SP file in the file location that you specify. So this location can be an ASM disk group or cluster system file or shared raw device. If you manually create your database, so it is recommended that you create an SP file from a P file. So all instances in the cluster database use the same SP file, because SP file is a binary file, and do not add it. And when SP file introduced, can anyone tell me in the message? SP file introduced in 9.9. Okay, so you can change the SP file setting by alter system command, or you can change in the P file, and then you can create SP file. So if SP file does not exist, then you specify P file in your startup command. So basically SP file simplify the administration, maintaining consistent parameter setting, and other things. Okay, so in addition, you can configure rman to backup your SP file. And in RAC, basically, if you see that how you will edit that by using alter system set command. Okay, in that you specify SID. If instance are a startup with an SP file, then SID equals to is the star is the default. If you do not specify the SID clause, is if you specify an instance other than the current instance, then a message sent to the instance to change the parameter values in its memory. If you are not using the SP file scope, because we know that scope is equal to memory, scope is equal to both, and scope is equal to SP file. So that is things related to SP file. Okay, so I'm not going into too deep. in the SP file. Now come to undo table space. So if you see that undo table space have undo 1, undo 2, undo 3, and in RAC 01 you have undo 3, in RAC 02 you have undo 2, and alter system undo table space equals to undo 3, SID equals to RAC 01. So this is the way you can change the undo table space. So as I said that undo table space basically is used to store undo segment, and only the instance assigned to the undo table space can modify the content of the table space. However, all instance can always excuse me, read all undo blocks for consistent read purposes. Any instance can update any undo table space during transaction recovery, as long as the undo table space is not currently used by another instance for undo generation or transaction recovery. So you assign undo table space in RAC database by specifying undo table space parameter. So for each instance, if you do not set undo table space parameter, each instance use the first available undo space undo table space for policy management database. So Oracle automatically allocate the undo table space when the instance is start. If you have OMF enabled, if you don't have OMF enabled, then it will be problem. Okay, and later on you can change by alter system set undo table space command. Okay. And you have manual undo management and you have auto. So you cannot use both, you have to recommend you have to use only one. So auto mode is recommended. Got it? Now come to redo threads or redo log files. So as you see that you have instance 1, instance 2, and you have online redo log file thread 1, online redo log file thread 2. So each instance redo thread must contain at least 2 redo groups, and each redo log group should contain at least 2 members, and that is mirror copy. If you create your RAC database using DBCA, then RAC database automatically implements a configuration, and you should create redo log group only if you're using administer manage database. For policy management database, if an instance starts due to a change in server pool cardinality, the Oracle database automatically create redo log files, enables a redo thread for the instance. If there is not a redo thread allocated to that instance, and creates the undo table space. If there is not an undo table space allocated to the instance, the database basically must be using Oracle managed file and Oracle ASM in the situation. So in RAC database, all redo log file reside on the shared storage, because readable is allowed between the instances, but writable is not allowed between the instances. Clear, guys? Now come to backup files in RAC. So we have RAC database file, we have redo log files, we have blockchain track file, we have control file, we have parameter file. So control file and parameter file, which comes auto backup. Blockchain track file, you have to take the backup. Redo log file backup, you have to take the archive log file backup. RAC database file, basically you can take the backup set, or you can create the image copies, or you have backup files. So this is the things related to backup. Not will go too much in that. And we know that from 12C we have multi-tenant database. So in multi-data database, whether a PDB is available on more than one instance of an Oracle RAC CDB. So CDB is basically managed by the services running on the PDB, and you can manually enable PDB access on each instance of an Oracle RAC CDB by starting the PDB manually on that instance. And in terms of database in memory, so each node in RAC environment has its own in memory column which basically stores the objects. That object can be table, partitions, blah blah, and that is storage is basically based on columnar format. Clear? Now come to very important concept, listener in RAC. So you can see that local listener, you can see that scan listener. So what is basically, and also you are saying MG empty listener. Have you heard about this? Basically, basically scan introduced in 11G. So scan means single client access name, means whenever client want to connect to the rack, so we give one name, that is single common, and it is for every client. So that's why it is called as single naming. Okay, and in that DNS basically resolve the name of this scan name, and they have three IP which you create in round robin fashion, and every IP has a scan listener. Okay, and the IP addresses assigned to scans are relocatable. Each scan IP will move to active node in the cluster if the current node fails. So scan listener is assigned to each scan IP, and the scan name should be configured in DNS. On that, three scan addresses may be assigned for the same scan name. So each database register with the scan listener and update with the current load metric. So the scan listener basically receive the request, and it will route the request to the local listener on the least loaded node, and the local listener is using basically a virtual IP address. So each node will have public IP assigned to network interface, and the MG-empty listener allows the cluster health monitor to communicate with grid infrastructure management repository. And in the cluster domain configuration, the GIMR must be configured in the domain services cluster DSC. So in a standalone cluster configuration, each cluster must have GIMR on one of the nodes. By default, it is created on the first node in the cluster. In Oracle Database Release 19C, the GIMR is optional but with reduced functionality. So from 19C, it is optional. Okay. So now cluster node. If you come with cluster node, so in cluster node you have database instance, you have ASM, you have clusterware processes, you have grid infrastructure home, you have local storage, you have database home, and then you have operating system. So cluster node is basically a server that is a member of a cluster. So there may be one or many nodes in the cluster. So each node has the local storage, I said already, which basically provides the operating system need and the grand infrastructure software installation. And every cluster node has an instance of cluster running, and ADR basically automatic diagnostic repository, and local copy for the OLR are both is stored in the node local storage. So please remember that. And each node must have access to shared storage, basically whatever things which is stored in the shared, that is available for all the nodes of the cluster. So a node basically may have one or more instance running of a RAC database, and it is possible to install the software for these instance on shared storage, but it is recommended that these be installed on local storage to allow rolling upgrade or relocation. So basically using local storage also increase your software maintenance cost, because each Oracle home must be upgraded or patched separately. So the cost can be migrated by using feed patching and provisioning. So each node has a network connection to what called the public network, and the network provides the connection application that use the database or cluster application. So each node has a private connection also called the interconnect. So that provides communication between the nodes of a cluster, and shared storage must be accessible from each node. Okay. Clear? So now come to cluster configuration options. So we have a standalone cluster, we have extended cluster, we have cluster domain, that is new. So what all about? So standalone cluster consists of one or more cluster node configuration with locally available shared storage, excuse me, a private interconnect, local instance of ASM, and for managing that shared storage, and the GIMR for storing cluster health and diagnostic information. Okay, and extended cluster is a special case of standalone cluster where the nodes of the cluster are in two or more sites at different locations. And cluster domain is basically a grouping of a cluster. A cluster domain consists of a single domain, service cluster, and a number of member cluster, and that utilize services offered on the domain service cluster. So management cluster receives services such as ASM or ACFS from a domain service cluster, and standalone cluster may be converted to a member cluster. So this is the way basically these things happen. So domain services cluster provides centralized and consolidate services that are consumed by the member cluster which registered with the domain service cluster. So these are the cluster configuration options. Okay. Now storage option, as we know that we have ASM, we have ACFS, we have ACFS remote, we have IBM AIX GPFS, OCFS2 for Linux, and ANFS. So a cluster basically required a shared storage area that is accessible to all the cluster members. So the support type of shared storage depend upon the platform you using. So ASM is strongly recommended, and network file system which is not supported on Linux, on Power, and on IBM Z series based Linux, and OCFS2 for Linux or general parallel file system on IBM platform, and ACFS, which is a general purpose cluster file system built on a ASM cluster. Okay, so the storage is presented to the operating system as block storage, such as a partition or as a file system, and such as a typical point and directory structure with ASM cluster file system. So any shared storage must be cluster aware and certified to use OracleRide database. Okay, so you cannot use OUI to install grid infrastructure binaries on block or RAR device. So you cannot put GI binaries and files on ACFS file. Clear? Excuse me. Two people left. Okay. So cluster domain. Cluster domain, if you see the figure, we have local ASM with OCFS, we have application member cluster, we have database member cluster, we have database member cluster, and below that we have domain services cluster. So GIMR, trace file analyzer, fleet patching, and ACFS, remote service, ASM service, IO service, and all attached to your shared ASM storage. So stand-alone cluster consists of one or more cluster with locally available shared storage, and private interconnect will basically local instance of ASM for managing that shared storage, and optionally to the GIMR for storing cluster health and diagnostic information. And cluster domain, as I said, is a grouping of cluster, and cluster domain consists of single domain plus service cluster and a number of member cluster, and that utilize services offered on the domain services cluster, and centralized and consolidated services are hosted by the domain services cluster and consumed by the member cluster that are registered with that domain service cluster. No extended cluster. What is the how you can see that? This is the extended cluster where you have one side and another side. There you have this. So extended cluster consists of nodes that are located in multiple location. Basically that calls is sites. So you can see this diagram where you have one site and where you have two sites. And when you deploy any standalone cluster, so you can choose to configure the cluster on Oracle Extended Cluster, and you can extend Oracle RAC cluster across two or more geographically separate sites, and each equipped with its own storage. Okay, there is no common storage, but communication happened between these two storage, right? So in the event that one of the sites fail, the other site acts in active standby, and the storage is replicated so that each site may function when another cluster is unavailable. So both Oracle ASM and Oracle Database Stack in general are designed to use enterprise class shared storage in a data center. So we use fiber channel technology and fiber cable, fiber channel and Ethernet cables. So these are the things required. So Oracle recommend that you deploy Oracle Extended Cluster with the normal redundancy disk group. Okay, so you can assign nodes and failure groups to the sites, and sites contain failure groups, and failure group contains disk. So for normal redundancy disk group, a disk group provides one level of failure protection and can tolerate the failure of either a site or a failure group. So recommended distance between the sites is less than how many kilometers? Can anyone tell me? Anyone knows that? No reply. 100 kilometers. 100 meters is very less, Shiva. Now grid infrastructure files. So we have grid infrastructure tools, that is OCR config, OCR check, OCR dump, CRS CTL, SRV CTL, CRS CTL query log. So basically all tools are available to manage the files and the database of RAC. Okay, so SRV CTL and CRV CTL will update the cluster resource information in the OCR, and the OLR is necessary, and the OLR is as necessary. Collectively, voting files and OCR are referred to an Oracle Clusterware files. Okay, so from Oracle 19C, grid infrastructure requires certain files and provide tools to access each. So each standalone cluster should have grid infrastructure management repository installed or be part of a domain service cluster having a GMIR. Okay, GIMR. So in 19C grid infrastructure, the GIMR is not required for standalone cluster, but recommended. If the GIMR is not installed and configured, several features are not available, such as cluster health advisor, fleet patching, and provisioning. Clear, guys? Now OCR, that is very important. Oracle Clusterware Repository. Basically, every node has OCR cache, and every node has CRSD process, and every node has client process, and we have a primary file and we have secondary file in that. So basically, cluster configuration information is maintained in the OCR. You can have up to how many OCR you can use in RAC? No idea? 5. So each OCR location must reside on shared storage that is accessible by all nodes, and OCR relies on distributed shared cache architecture, and each node in the cluster maintain in-memory copy of OCR along with the CRSD that access the OCR cache. Only one of the CRSD process actually read from and writes to the OCR file on shared storage. So this process is responsible for refreshing its own local cache as well as the other OCR cache on other node in the cluster. Okay. So for query against the cluster repository, the OCR clients communicate directly with the local CRS daemon, that is CRSD process on the node from which they originate. When clients need to update the OCR, they communicate through local CRSD process to the CRE process that is performing input output IO for writing to the repository on disk. So main OCR client application are CRSCTL OUI, SRVCTL, Enterprise Manager, DBCA, Database Upgrade Assistant, Network Configuration Assistant, and ASMCA. And OCR maintains dependency and status information for Oracle for application resource defined in Oracle Clusterware, especially you can say database instances, services, and node application. Okay. And you can see in the figure in node 2, we don't have a client process, right? But Oracle intentionally not mentioned client process because of the clarity of this concept. Okay. Now voting disk, as you can see that voting disk basically check the heartbeats between the two nodes, between the nodes to the voting disk. So if any node miscommunication happen, then that node will be kicked out. Okay. So how it will be? So CSSD is the service which actually determines which node in the cluster are available and provides cluster group membership and simple locking services to other processes. So CSS basically determine node availability via communication through private network with the voting file used as a secondary communication mechanism. So this is done by sending network heartbeat message through the private network and writing a disk heartbeat to the voting file. In the diagram, you can see that. So voting file reside on a clustered file system that is accessible to all nodes in the cluster, and its primary purpose is to help the situation where private network communication fails. So the voting file is then basically used to communicate the node state information to other node. So in the cluster without the voting file, it can be difficult for isolated nodes to determine whether it is experiencing a network failure or whether the other nodes are no longer available. That is different thing, Tanvir. So it can be difficult it would then be possible for the cluster to enter a state where multiple subcluster of nodes would have unsynchronized access to the same data file. So node 3, if you see in the diagram, node 3 can no longer send network heartbeat to other member of the cluster when other nodes can no longer see node 3 heartbeat. So they decide to evict that node by using the voting disk. So when node 3 reads the removal message or kill block, it generally reboot itself to ensure that all outstanding write IO are lost. Now get it, Tanveer Hussain? So split brain condition is generally where one of the node cannot talk to other nodes via network, but it is still able to access voting disk and can happen for any number of reasons. So the primary causes are that a cluster node is unable to respond to the heartbeat request from another node. So that this can be caused by network failure, interruptions, hardware failure, software failure, and resource starvation. So there are many causes, but Oracle Clusterware has very conservative design to absolutely guarantee the integrity of the cluster and the data. Clear? Now see that Clusterware tool for installing, configuration, and managing Oracle RAC. So we have CVU, we have ORA-CHK, we have OEM, we have SRVCTL, we have CRSCTL, we have OCR check, OCR dem, and OCR config. So these tools are basically used for doing the installation, configuration, and managing the RAC. So OCR config is basically manage the OCR dump basically to view the OCR and OLR contents. OCR check basically display the version of OCR black format, and CRSCTL basically it will use for CSSS, CRS, and event manager, and SRVCTL is basically used for OCR, ONS, virtual IP, and OEM is used for to manage single and RAC database and Oracle cluster, and Oracle ASM ORACHK performs a health check for the Oracle software, and CVU, as I told earlier, uh, about the pre and post installation check. Now see how your server network configuration happen. So see that private network, there is network switch, and private IP, we have storage network, shared storage, and scan listener that have public network, and VIP local listener attach, and public IP scan listener attach. So this is the configuration. So each cluster requires certain network resources. It must have public network access for clients and private network for cluster interconnect, and a minimum is 2 network interface card required, and the storage network is only needed for network attached storage, otherwise NAS, network attached storage, otherwise it is not needed. Now come to Clusterware processes and services. So we have many processes. For that you have to do much things, but Oracle Clusterware consists of 2 separate technology stack. One is upper technology stack, that is anchored by CRS and CRS daemon, and lower technology or lower technology stack anchored by OHASD. So the cluster components basically based on platform. So you can use add node.sh script to add node to existing cluster. So in Oracle 19c grid infrastructure, you can use the installer grid setup.sh or the fleet patching and provisioning utility to add a new node to an existing cluster. So that is the new feature in 19c. Now I said that cluster ready services. So you have in that you have CRS, CSS, ASM, CTSS, EVM, GNS, Aura agent, ONS, and Aura root agent. So these are the things which belongs to the CRS. And in OHAS you have app agent, script agent, ologger, GIPC, GPNPD, MDNS, Aura agent, Aura root agent, OSysMon. So I'm not going into that detail. It is too vast to add here. So little bit I can do that. That is ONS, basically used for Oracle notification services. So in that events are generated when resource change. So Oracle Notification Service is a facility that creates a bridge with middle tier servers or application to transport these events to application logic for handling or reaction. So ONS is a part of large framework is known as FAN, Fast Application Notification. So with FAN application, use these events to achieve very fast detection of failure and rebalancing of connection pools. So when FAN is used together with Oracle database, the advanced queuing features allowed and HA events to be received by external application. Okay, so in the diagram you can see that. Excuse me. Now global name service, what is that? If you see that GPNP service is collectively provided by all the GPNP agent. So it is a distributed method of replicating profiles. So the service basically installed on each node in the domain as a GPNP agent. So this service is basically peer-to-peer. There is no master process. This allows high availability because any GNP agent can crash and new nodes will still be serviced. So GPNP requires standard IP multicast protocol provided by MDNS to locate peer service. So use multicast discovery, GPNP locates pair without configuration. So this is how GPNP agent on a new node locates another agent, and that may have a profile it should use. Okay, so name resolution is also that the part of GPNP. So a name defined within a GPNP domain is resolved in many cases. So that we covered later on in different section. Client server pool. So you have see that free pool, generic pool, and user created pool. Excuse me. So when Oracle Clusterware is installed, two internal server pools are created automatically, generic and free. So all servers in a new installation are assigned to free server pool initially, and servers moves from free to newly defined server pools automatically. So basically Oracle RAC database supports two server pool management, basically style and deployment models. So policy based management and administrative management is used in that. Okay, If you create RAC one node database, so Oracle RAC one node runs only in one server pool. So this server pool is treated the same as any other service pool. Okay. Okay. So this is a cluster server pool, and if you go into this section, ASM. So little bit I have added in ASM. So everyone knows about ASM. So in ASM, that is required for installation of that. So all ASM installation can be configured with Oracle ASM Flex client. So there is hub node, node 1, node 2, node 3, node 4, node 5, like that. And that is basically from 19C, which is recommended. And ASM instance is local to the database instance, and in the past this was the only configuration available. So each node had to have an ASM instance if ASM was used to provide shared storage. So if you can see that hub node 2 is an ASM client node, and it uses the ASM service on hub node 3, and another nodes in the cluster to access the metadata, and then does direct access to the ASM disk storage to the data block. So this is the typical picture, and you can see ASM instance. So ASM instance has its own memory, but that is not equivalent to your database SGA and ASM background process. And ASM performs fewer tasks as compared to database. So ASM SGA is smaller than database SGA, and the instance represent the CPU and RAM, and the SGA in the SM instance is different in terms of database SGA. So the SGA in the SM instance is divided into 4 areas, that is shared pool, large pool, ASM cache, free memory. So shared pool is used for metadata information, large pool used for parallel operation, ASM cache used for reading and writing blocks during rebalancing operation, and free memory is unallocated memory. So the minimum recommendation amount of memory for ASM instance is how much MB? Anyone can tell that? Any idea? No one is answering. Okay, 256 MB. And in ASM we have CKPT, we have DBWR, we have DIAG, we have LGWR, we have PMON, we have PSPO, that is process spawn processor, SMON, and VKTM, virtual keeper of the time process, and M and the memory manager process. And also it has LMON, the SM instance. Some of these processes include the following: LMON, LMDN, LMSN, LCKN. And additional processes are started when ADVM volumes are configured, that is VDBG, VBGN, VMB. So these are the processes. So that processes is important. And now disk storage, if you see that is ASM and CFS both use ASM disk storage, and ASM presents disk group to the database as mounted stage, and ACFS presents ADVM volume to the operating system as mount point. So this is the difference between them. Okay. Now come to ASM disk group. So you can see that in ASM disk group is used to manage for storage properties such as redundancy, access control, and allowed before drop. So physical disks are assigned to this group, and this group provides the functionality of RAID with much more flexible. So this group must have unique name in ASM instance, and all disks in a disk group must be equal size. So a disk can belong to one and only one disk group. Okay, so we know that we have external, normal, high, flux, and extended settings. When you specify external redundancy, Oracle ASM does not provide mirroring. If you specify normal redundancy, Oracle ASM provides two-way mirroring by default. When you specify high redundancy, Oracle ASM provides three-way mirroring. When you specify flex or extended redundancy, the group redundancy is overridden by the file group redundancy property. So extended redundancy provides two-way mirroring by default. So that is about redundancy. Okay. Now file groups. If you see that file group basically code, this group contains at least one file group, the default file group. This group can contain multiple file groups. This group must have flux or extended redundancy. This group can store belonging to multiple databases, with each database having a separate file. So there are many things regarding that. So a database can have only one file group in a disk group. Database can span multiple disk group with the multiple file groups in this group actually, and file group can belong to only one disk group. Okay, so when a database PDB or CDB is created, if existing file group has client ID or name that match the ID or name of the database, so PDB or CDB, then that file group is used to describe its file. Otherwise, a new file group is created for the database for PDB or CDB. ASM tools. So like database tools, we have ASM tools. So same basically. So we have ASM CMD, we have ASF SUITL, and we have ASMCA, we have SQL Star Plus, we have ACFS Remote, that is new. So by that you can manage ASM. And ACFS cluster file system, as I said, that extend Oracle ASM functionality to support all customer files. So ACFS presents a mountable file system to any cluster node that can access ASM. So if you see that there is ACFS file system, and then ADVM, then IO for shared storage, then this ASM instance, ASM proxy, and then metadata transferred between ADVM and ASM proxy. Now ACFS remote file system, what is that? When you are using Oracle ACFS deployment on the cluster domain service, or you can say Oracle Domain Services Cluster. So Oracle ACFS provides Oracle ACFS remote service for native Oracle ACFS functionality on Oracle Database Member Cluster with no attached local storage. Okay, so Oracle ACFS remote service can be used for both application cluster as well as Oracle database member cluster to enable a flexible and file system based deployment application of database. Now come to fleet patching and provisioning and maintenance. So in fleet patching, basically formerly we called as rapid home provisioning. So that is basically a server which has one or more nodes in a cluster configuration, and it must have GI software installed. It is recommended that ASM configured with ACFS is used for storage of image file, but other file systems are supported, and it must have grid naming services and a management DB. So these are the same components that make up the domain service cluster in a domain cluster, but the domain does not have to be in a domain cluster. So that is the difference. Now, how your FPP workflow happens? So it will actually create a gold image for software home, and that was previously installed with OUI, and use the RHPCTL import command for the first gold image, and you may run this command from the RHP server or RHP client. So you can create gold image from either a source home or from a working copy using the RHPCTL and image command. Then after that, you will add the client to the PHP server. This client is required to have the OS installed and cluster ready. And then third, create a working copies of the image, and on the server, local file system, on the RHP client or NFS mount point. And then patching a target follows a similar process. So this is FPP workflow. Now this is very important process startup. So first init will start the OHSD process, then OHSD process will start CSSD monitor, Aura agent, Aura root agent, and CSSD agent. So this is level 1, and after that Aura agent will start these process, and Aura root agent will start these, and CSSD agent will start only CSSD. And then CRSD will spawn two process, that is CRSD Aura root agent and Aura agent, and then CRSD Aura root agent basically start these process, and these process start with CRSD Aura agent. So this is the grid infrastructure processes which start in level 0, level 1, level 2, level 3, level 4. And this is the Oracle RAC performance enhancing feature. So we know that in 9i automatic unju management, cache fusion, RAC CAMES, in 10G local global partition index, connection load balancing advisory, cluster managed service, and ASM, that is big storage things. And then 11G universal pool, support for distributed transaction, parallel execution in RAC, and locking and read mostly object. And in 12C, they have PDB, service isolation, self-tuning, LMS, multi-thread cache fusion, and smart fusion, Exa fusion, PDB, session affinity, and service-oriented buffer cache. And in 18C, they have scalable sequences, commit cache, database reliability framework. And in 19C, they have dynamic resource allocation features. So these are the features which introduce. So that's it. And thank you. So this is all about the RAC architecture.